Hi there. Welcome to Cats in the City, by Sith Sense. I'm Johnny.
And I'm Pearl.
Together, we would like to share with you pieces of interesting knowledge that we find.
And that could be useful to you in the future.
Pearl, can you help me solve this puzzle?
Let me see. Oh, is this a Sudoku puzzle?
Yes, it's a Sudoku puzzle. Are you familiar with this puzzle?
I have heard of this puzzle before, but I have never played one. Can you tell me the rules of this puzzle?
Well, you see, the rules are really quite simple. Sudoku is a logic-based number placement game that is played on a 9x9 grid. The goal of the game is to fill each row, column, and 3x3 subgrid with the numbers 1 to 9, without repeating any numbers in the same row, same column, or same subgrid.
I see. In the beginning some of the cells have been filled with numbers, while some are empty.
Yes, to solve a Sudoku puzzle, you must use logic and deduction to fill in the missing numbers. The pre-filled cells are clues to help you eliminate possibilities in other cells, and continue filling in the puzzle until all cells are filled with numbers that satisfy the rules of Sudoku.
I now understand the game and have come up with a strategy to solve the puzzle. However, before I share my solution, can you please explain to our audience what a recursive function is in Python?
Simple, a recursive function in Python is a function that calls itself repeatedly, until a certain condition is met.
Good. Can you guess what's my strategy to solve a Sudoku puzzle?
Are you saying that you want to use recursive function in Python to solve a Sudoku puzzle? I'm not sure I understand how a recursive function could be used to solve a Sudoku puzzle.
Let me rephrase the rules of Sudoku in a logical manner. There are essentially only two rules to follow in a Sudoku puzzle. The first rule is that an empty cell can be filled with a number only if that number is not already present in the same row, same column, or same 3x3 subgrid. The second rule is that once that particular number has been placed in that particular empty cell, another number is filled in the next empty cell, that must also follow these rules in order to achieve a valid solution, and the cell after that, and so on and so forth, until the last empty cell has been filled.
I think I understand your strategy now. We can use brute force in Python to solve a Sudoku puzzle. We'll just try every possible numbers in an empty cell until we found a valid solution.
Well, it's not really brute force, but you are not entirely wrong too. The proper name for this strategy is backtracking. At one cell, you make a decision and choose a number. At the next cell, you choose another number. If you couldn't choose a valid number, you backtrack to the previous cell and choose a different valid number, and then you continue on like this, until all the empty cells are filled.
We can easily do this by using loops and if statements in Python. Let's do it now. I'm very excited to see how we can code a program in Python to solve a Sudoku puzzle.
Okay. As usual, let's start with a docstring. I would like to put a disclaimer here. This program is able to solve most Sudoku puzzles but not all.
There are Sudoku puzzles out there that are very difficult, that only an expert could solve. These experts use a variety of advanced techniques to solve these puzzles. I don't expect our simple program could emulate their expertise.
My strategy using recursive function does not imitate the way a human would solve a Sudoku puzzle. A human will use visual input and logical deduction methods to solve the puzzle. Some of those deduction methods are very advanced Sudoku techniques.
We can code these advanced techniques into our program, and it will imitate the way a human would solve a Sudoku puzzle, but that's a very challenging program to code. Maybe when you are very confident of your coding skill, you can try to build such a program.
That's true. Moreover, our program is only tackling a 9x9 grid layout. There are other Sudoku layouts out there, but for simplicity, we'll focus on the most popular 9x9 grid layout.
In our program, we'll label the empty cell using the integer 0 and we'll name the 3x3 subgrid as a box. These terminologies are specific to our program. You can label and name them any way you like.
In a Sudoku grid, we can label each row as an integer from 0 to 8. Similarly, we do the same for each column. This way, we can label each cell as the intercepting point of row and column. For example, the first cell in row 3 is 30, the next one is 31, and then 32, and so on until 38.
So, for a given row, the row number never changes but the column number progresses from 0 to 8. Similarly, we'll do the same for a given column. For example, the first cell in column 4 is 04, the next one is 14, and then 24, and so on until 84.
In our labeling convention just now, we named the row before the column. There's no particular reason for this. You can, if you want to, put the column before the row.
However, you must be consistent when labeling the cell. In our program, we'll name the row before the column, because that's how we'll input the Sudoku puzzle into our program.
We'll input our Sudoku puzzle into our program like this, by using a list-in-list method. We'll name the list as grid. In this way, our grid list has 9 sublists, each sublist represents a row in the puzzle, and the index of each item in the sublist refers to the column.
Remember how we access the item in a list? In our grid list, grid 23 refers to the item with index 3, in the sublist with index 2, or in terms of the Sudoku grid, it is cell at row 2, column 3.
Now that we've decided on how to name the cells in a Sudoku puzzle, how about the box or the subgrid?
That's easy, we'll just use the top left corner cell of each box as the label for that box. For example, box number 6 is labeled as 36, while box number 7 is 60. In other words, cell 47 belongs to box 36, while cell 82 belongs to box 60.
We'll show you a very clever trick later, how we can use some basic mathematical operations to derive the label for each box.
Moving on to our first function. This function will check if a number is allowed to be filled in a cell. The rules are quite simple and straightforward. The trick is how to represent the rules using codes that can be understood by our program, that will perform the tasks required.
I think that by now, many of our audience members have come to realize that coding can be simple and straightforward. However, when it comes to representing the real world, some level of creativity and ingenuity is required in our code. And that's the beauty of programming.
We pass a few parameters to our first function. G for grid, R for row, C for column and N for number. This function will check that, for cell RC, is the number N allowed in that cell?
In our strategy, we'll first check if the number N has ever appeared in row R, then we'll check the same number N for column C. And finally, we'll check the box where cell RC is located for the number N.
So, for row R, by using a for loop, for x in range 9, if grid Rx is equal to N, return false. In this code sentence, row R is fixed, the value of R never changes. X on the other hand, progresses from 0 to 8. So, we are essentially checking each cell in row R, looking for the number N. If the number N has appeared in another cell in row R, that number N is not allowed anymore in cell RC, so the function will return a false value.
Similarly, the next code sentence will perform the same check on column C, Y is the row number and it will progress from 0 to 8. If our program finds the number N in another cell in column C, the function will return false, meaning that number N is not allowed in cell RC.
Lastly, if the number N never appears in row R and column C, we'll need to do the final check on the box that cell RC belongs to. To do that, we'll first need to determine which box does cell RC belongs to.
The floor division operator can be used for this purpose, and it's often referred to as the integer division operator. When using floor division, the result returned is the quotient of a division. The quotient is the largest integer that is less than or equal to the normal division result, that's why I prefer to call it the integer division operator. In Python, the floor division operator is denoted by a symbol consisting of 2 forward slashes.
For example, the 0, 1, 2 integer divided by 3 will result in 0, while number 3, 4, 5 will be 1 and finally 6, 7, 8 will be 2. By multiplying these quotient integers by 3, we'll get 0, 3, and 6, which are the labels for our boxes. How clever is that?
Indeed, it's a very clever trick. Then, using a nested for loops, we'll check every cell in that particular box for the number n.
Take note that boxes are subgrid of 3 by 3 cells. So, the progression steps are 0, 1, and 2 only. That's why we use range 3 in our code.
For example, in box 36, for row 3, we'll only check cell 36, 37, and 38. Then we move to the next row, which is row 4, and finally row 5, while at the same time, checking column 6, 7, and 9 only.
At the end of our function, if the number n passes all the 3 tests, which means the number n is allowed in the cell RC, our function will return a true value.
This function is quite complex, as it involves a significant amount of creative logical reasoning. Therefore, you may want to pause the video at this point and take your time to study the function carefully, so that you can fully comprehend it.
Our program is actually quite short because it has only 2 functions. We have gone through the first function, let's move on to the second function.
We'll call the second function, solve, that will take 3 parameters only. As usual, G refers to our grid, R is row, and C is column.
When we write R equals 0, it means that this function can take the value of R as its parameter, but if R value is not provided, it will take 0 as the default value.
Similarly for C equals 0, unless a value of C is provided, the function will take 0 as the default value for C. This is a very convenient way of defining a function, especially if the parameter has a default value.
The default value of 0 for both R and C means that our solve function will start at the first cell, cell 00. Later, you'll see the code used to tell our program to progressively move one cell at a time in our grid until it reaches the last cell.
Let's briefly go through this function. Notice that the function calls itself. This is the trademark of a recursive function. Recursive functions are not unique to Python. A recursive function is a programming technique that can be used in many programming languages, including Java, C++, JavaScript, and many others.
The concept of recursion is a fundamental programming concept that has many applications. Building a recursive function is a very useful skill that's transferable across different languages and platforms.
For a recursive function to work properly, you must define the base case. In essence, a recursive function serves as a roadmap for our program, and the base case represents the final destination in that roadmap.
When coding a recursive function, you should always define the base case first. In our case, that's when our program has reached the last cell in the grid.
Moving to the next cell is represented arithmetically as adding 1 to the column value. Our program can move to the next cell easily by adding 1 to the column value. However, when we are at the last column, i.e. column 8, adding 1 to move to the next cell is a bit different. We are actually moving to the next row, hence when column is greater than 8, we add 1 to the row value and reset column to value 0.
However, if the current row value is 8, which means we are at the last row, we cannot move to the next row anymore. This is the last cell in our grid, which means that our recursive function has reached its endpoint and it should terminate at this point.
Since some cells in the grid are pre-filled and not empty, our program must be designed to avoid changing the value of these cells. Instead, the program should skip over these cells and focus only on the remaining empty cells.
We can code this behavior like this: if cell RC has a value that is greater than 0, we should move on and solve the next cell, by adding 1 to the column value.
We'll use a for loop to call our first function. If the number n is allowed in the cell RC, we'll set the value of that cell to that number n.
Just a moment, let me clarify that the for loop iterates through the numbers from 0 to 8 in a specific order, starting with 0 and ending with 8. It's important to note that for a given cell, there may be multiple numbers that are allowed based on the current state of the puzzle. Therefore, the first allowable number that the loop encounters for a cell, may not necessarily be the correct solution for that cell.
That's the power of recursive function. Notice that the solution cell RC is set to number n, is conditional. The solution is accepted only if the solution for the next cell is also valid, and since it is a recursive function, the solution for the next cell is only accepted if the solution for the cell after that is also valid.
I see, each solution is dependent on the next solution being valid, and this process keeps going until our program reaches the last cell. If the solution for the last cell is valid, the solution for the cell before that is validated, which in turn validates the solution for the cell before that. Our program moves forward conditionally, but the solution tracing and validation happens backward. That's why we call this strategy backtracking.
Yes, you are correct. The next line of code is very important. If a given number is allowed in cell RC but the solution for the next cell is invalid, our program will move to the next line of code. This line of code serves to reset the value of cell RC to 0, and restart the for loop, which will iterate to the next number allowed.
The last line of code in this function returns a false value. This means that the solve function was unable to solve the Sudoku puzzle. If everything goes well, our program should never reach this line.
As usual, we'll write a main code for our program. The main code is actually very simple. If solve function returns a true value, meaning that it has solved the puzzle, we'll use a nested for loops to print our grid. As per our convention in this program, I refers to the row, and j refers to the column.
The print function in Python has a built-in parameter called end, which determines what should be printed at the end of the line. By default, end is set to \n, which means that the output will move to the next line after each call of the print function.
However, in our program, we are iterating through the values of j, to print the values of the cells in the same row. To achieve this, we set the end parameter to a space character, which means that after printing the value of the current cell, the output will not move to the next line, but will continue on the same line with a space character in between. After the last cell of the row is printed, i.e. when j equals 8, we set the end parameter back to its default value, \n, to move the output to the next line and begin printing the next row.
If our program was unable to solve the puzzle, the solve function will return a false value, and this will trigger the else statement, and print the statement, unable to solve the Sudoku.
Let's try running our program to solve your Sudoku puzzle. I have input your puzzle as the list grid.
Yes, let's run it now.
Wow, the puzzle was solved almost instantaneously. It's amazing.
To our audience, when you are running the program, please ensure that the grid list contains a valid Sudoku puzzle. You cannot simply put random numbers in the grid list, or the puzzle will become unsolvable.
Copying a puzzle is tedious and prone to mistake. I would like to challenge our audience to think of a better way to copy the puzzle into our program. Maybe you can key in the puzzle as a list of 9 digits numbers.
You can try replacing the commas with spaces or any other symbols.
Similarly, you can use other number or symbol to represent the empty cells.
Most of these changes have impact on our code, so remember to edit the code where it's applicable. You can also add some cosmetic effects to the output by modifying the print function.
Once you have built your own Sudoku solver program, you should test your program on various Sudoku puzzles that you could find in books or online.
You should challenge the program to solve very difficult Sudoku puzzles, to see the limit of the program. Easy puzzles are usually solved almost instantaneously. As puzzles gets harder, the time to solve them gets longer.
Take note that some puzzles are unsolvable with a recursive function. For puzzles like these, the recursion will go on infinitely, but you will never get a solution.
Python has a built-in recursion limit, which set at 1000 recursive depth. Don't wait for the program to reach this limit, it may take hours.
Instead, you can set a time limit to our code. For example, if the recursive function could not solve the puzzle in 5 minutes, it will return a false value, and terminate itself.
You can search online for code examples for these time limiter. Good websites include Stack Overflow, Geeks for Geeks, etc.
If you searched online, you'll find a lot of different ways you can code a Sudoku solver. Some are very basic like ours, others may be very advanced that import many modules and libraries. Once you master the code, the sky is the limit. Happy coding!
That's all from us this time. I'm Johnny.
And I'm Pearl.
Bringing you bits and pieces of interesting knowledge from cats in the city.
Thanks and see you next time.